Professor Anish Vora, and I welcome you all in this video lecture. In this video lecture, we'll study about decimal to octal number conversion. In previous lectures, we have seen how decimal number can be converted into binary and binary number can be converted into decimal. So in this video lecture, we'll start with decimal to octal, and then in next video lecture, we'll see how octal number can be converted into decimal. So first we take a look at octal number. In case of octal number, we have total 8 bits. In decimal number, we have total 10 bits or 10 digits, and that is 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 10 digit we use for decimal number system, and that is why it is known as decimal number system. Same way in binary, we use 2 digit, that is either 0 or 1, and that is why it is known as a binary number system. Same way in octal number system, we have total 8 bits, and that is 0 to 7, 0, 1, 2, 3, 4, 5, 6 and 7, and that is why the name is octal. In case of octal number, base, or we call it radix, that is 8. To compare with decimal and binary, in case of decimal we know that base is 10, and in binary the base is 2. This is a decimal number and equivalent octal number. So in case of decimal up to 0 to 7, we have equivalent octal number, and that is exactly equal, and that is also 0 to 7. As I said earlier, in case of octal number system, we have total 8 digit, and that is from 0 to 7, and that is single digit. Now if we want to increase our number beyond 7, then we have to use 2 digit. Now let us start conversion from decimal to octal, and we have 2 steps. Let us study about step number 1 for integer values. To convert integer values of decimal number into equivalent octal number, we need to divide decimal number repeatedly by 8 until quotient becomes 0 and a remainder will give equivalent octal values. The step is exactly similar which we used while converting decimal number into binary number. And step number 2, that is for the fractional value. In decimal number we might have either integer value or fractional value or mixed value, that is a combination of integer as well as fractional value. So for fractional value we have another step, and that is to convert fractional values of decimal number into equivalent octal number. We need to multiply decimal number repeatedly by 8. So for integer value there is a repeatedly division by 8. For fractional value we have a repeatedly multiplication by 8. So now let us take one example, and then it will be very much clear for you. Let us take one decimal number, and it is 1024. So now we know that we have to use a ladder method, and we repeatedly divide by 8. So 1024. Now let us divide by 8. Then quotient will be 128. When we divide 1024 by 8, then quotient will be 128 and remainder 0. In this case remainder is 0. Again, if we divide 128, that is our quotient, by 8, then quotient will be 16 and a remainder will be 0. In case of 16 again, if we divide by 8, then quotient will be 2 and a remainder will again 0. If we divide quotient 2 by 8, then division may not be possible. So we have to write quotient 0. At this stage, when quotient becomes 0, we have to stop, we have to terminate our process of division, and last quotient, that was 2, it becomes a remainder. So now remainder will give you equivalent octal number. So again, it is LSB, MSB, and we write from LSB to MSB. So 1024, that was decimal number, and exactly equivalent octal number, that is 2000. You can notice in this stage that this is 2 is your most significant bit, 2000. So we can write 2000, right? You write from LSB to MSB or MSB to LSB, it doesn't matter, but you should know the position where LSB is and where MSB is. So this way we can do conversion from decimal number to equivalent octal number. Let us take one more example. Suppose we take one more decimal number, and that is 888. Now to convert this decimal number into octal number, we know that we have to divide repeatedly by 8. So we use the ladder method. We divide by 8 and quotient will be 111. In this case, a remainder will be 0. Again, if we divide 111 by 8, then quotient will be 13, and in this case, a remainder will be 7. You should notice that a remainder will be always between 0 to 7, right? It never goes beyond the 7. That is why, because our octal number has a single value, and that is between 0 to 7. If we divide 13, that is our quotient, by 8, then remainder will be 1. Quotient will be 1, and remainder is 5. Again, if we divide our quotient by 8, then division may not be possible. We have to write quotient as 0. We can terminate our process at this stage, and the last quotient, that was 1, it becomes a remainder. So now we know where LSB is, where MSB is. We write from LSB to MSB. So 888 decimal number and equivalent octal number, that is 1570. How to write that you must know, and in binary also we use same system. So now you are very familiar with this LSB and MSB system and how to write these numbers. We can take one more example with fractional values, right? So let us take one fractional value, and then you can know that how fractional value of decimal number can be converted into octal number. Let us take one number, that is 0.6. So in case of fractional value, to convert from decimal to octal, we know that we have to repeatedly multiply by 8. So let us multiply by 8.6. So it will give you 4.8. Now you should notice at this stage that the produce, this is known as a product. 0.6 multiplied by 8, that is a product, and this is known as a produce. So in produce we can observe that there is a combination of integer as well as fractional value. 4, that is our integer value, and 0.8, that is our fractional value. So again, we have to separate integer value as well as fractional value. Integer value we can take apart, and fractional value we can take again for repeated multiplication. So in case of 4.8, 4 is our integer value, so we are taking 4 aside, and 0.8 we are taking back for a repeated multiplication with 8. So if we multiply 0.8 with 8, then answer will be 6.4. In the produce, 6 is an integer value. We have to take integer value apart. So 6 we have taken aside, and 0.4 we have taken back, that is fractional value for multiplication. So again, answer is 3.2. 3 is an integer number, we are taking outside. 0.2 we are taking back for the multiplication with 8. Answer is 1.6. 1 we are taking apart. 0.6 we are taking fractional value for repeated multiplication. Answer is 4.8. 4 integer value we are taking. Say now here also to terminate the process we have two conditions. Either fractional value comes to 0, then we can terminate our process, or maximum for 3, 4 or at the most maximum for 5 multiplication we can go, but then we can terminate our process, right? So we have done 5 multiplication. There is no need to go up to 5 most of the time, but we have gone up to 5. So we can terminate our process, and the integer values we have taken aside, that can be our equivalent octal number. And we have to write from top to bottom, right? So we have to write from top to bottom. So 0.6, that was our decimal number, and exactly equivalent octal number, that is 0.46314. 0.46314. That is our equivalent octal number. So this way we can convert our decimal number into octal number for fractional value also. Now let us take one more mixed number. This is decimal number, mixed number. It has an integer value as well as it has fractional value. So 2419, that is our integer value of the decimal number, and 0.78, that is fractional value. So to convert this decimal number into equivalent octal number, we have to do two processes, one for integer number and one for fractional value. So let us start with integer value, that is 2419. To convert integer number, we know that we use a ladder method, and we do a repeated division by 8. So if we divide 2419 by 8, then quotient will be 302 and remainder will be 3. If we again divide quotient 302 by 8, then quotient will be 37 and remainder will be 6. If we divide 37 by 8, then quotient will be 4 and remainder will be 5. Now this system, you know that how to take quotient and how to find a remainder. In this case 8 4s are 32, so 37 minus 32, so 5 is a remainder. If we divide quotient 4 by 8, then that division may not be possible, so we write quotient as 0, and we can terminate our process of repeated division at this point. But last quotient, that was 4, and that automatically becomes a remainder. So now we terminate our process at this stage. We have LSB, we have MSB, and we know how to write from LSB to MSB. So our integer part of decimal number, that is 2419, that we have converted into equivalent octal number, and that is 4563. 4 is most significant bit we can observe at this stage, and 3, that is LSB. So 3654. So we know that how to write this number. And in decimal number we have a mixed number. So 2419, that was integer number, and we have converted into equivalent octal number. But now 0.78, that is our fractional value, and we know that how to convert fractional value from decimal to octal. So we go for a repeated multiplication by 8. So 0.78 multiplied by 8, then it comes to 6.24. 6 is the integer value of the produce. In produce we have 6.24. 0.24, that is fractional value, and 6, that is our integer value. So we have to separate integer value and fractional value. Integer value we are taking aside, and the fractional value we are taking back for the repeated multiplication by the 8. So 6 we have taken integer value aside. 0.24 we have taken back for repeated multiplication with 8, and we get produce, and that is 1.92. 1 is integer number in the produce, we have taken apart, and 0.92, that is fractional value, we are taking back for the repeated multiplication. Again we get 7.36. 7 is a integer value. 0.36 we are taking back for the multiplication with 8. Then we get 2.88. 2 is integer value, we are taking aside. 0.88 we are taking for again repeated multiplication with 8, and produce we are getting, that is 7.04. So 7 integer value we have taken aside, and now we can observe that fractional value, that is 0.04, and it is very near to 0. So we can terminate our process of repeated multiplication at this point. As I said earlier that we can go for 3, 4 or maximum 5 repeated multiplication, and then we can terminate our process. So now we have an answer, that is 0.78 decimal number and exactly equivalent octal number, that is 0.61727. In case of fractional value, we have to write from top to bottom 61727. And so for overall mixed number, that was 2419.78 decimal number, and equivalent octal number we are getting, that is 4563.61727. So this way we can convert our decimal number into octal number. Number may be integer value, may be fractional value, or it may be a combination of integer as well as fractional number, that is mixed number. But I hope you have understood the conversion process very properly. Do some practice on your own. Thank you for watching my video. Keep watching. Thank you very much.